Thank you for joining us today. I'll be presenting our paper titled Semantic Web Accessibility Testing via Hierarchical Visual Analysis. I will start with a brief introduction to the problem and then discuss the solution that we're proposing to address this issue, and then finally present some evaluation results. So when you have a web app, a typical web app contains lots of content that are conveyed visually. So you have different navigation menus, you have different sections of the page. You have search region, you have image contents, you have various sorts of contents that are communicated visually to sighted users. So they can easily they can easily, just by one look, they can visually understand the structure and the content of the page and navigate accordingly. However, for visually impaired users, that visual communication is not available. So if you have a web app, that web app cannot be visually perceived, and they cannot understand the visual contents of the web app, so therefore they cannot interact with it. And this issue is basically what software accessibility is focusing on, which is how can we make software usable by people with disabilities? And particularly, we're talking about visual disabilities in this context, because the web is predominantly a visual medium, and that's the focus at this point. This issue of accessibility impacts millions of people around the world, and it used to be a nice to have feature. It used to be like an afterthought in many software products, but it's increasingly becoming a legal requirement in many jurisdictions, that a legal requirement that has to be fulfilled, and there has been many lawsuits regarding this particular issue. So the current practice for web accessibility is based on a W3C standard referred to as ARIA, which stands for accessible rich internet applications. So the way it works is you have a web app that adopts this ARIA standard or ARIA guidelines, and by adopting that standard, the web app would include certain attributes and features in the HTML itself, following the ARIA guidelines. And then this web app is passed to a tool that's referred to as a screen reader. So what the screen reader does, it parses this HTML file that contains the ARIA attributes, and then it automatically generates an audio representation of that HTML file. So then, instead of having a visual communication, you have an audible communication for visually impaired users, so they're able to understand, using audio information, they're able to understand the contents and the functionality available in that web app. So the existing tools, there are existing tools that basically check for that a web app is compliant with ARIA. But these tools focus on syntax checks. So for instance, one ARIA rule says that image elements must have a non-empty alt attribute. So alt stands for alternative text, which is basically a textual description of the content of the image itself. So when an image is presented, the screen reader would read out loud the content of the alt text in order to convey, in an audible fashion, to convey the content of that image. Another example is that input elements cannot be descendant of hyperlink elements, A elements. So in order to avoid the overlapping of input and hyperlink elements. So this is again another ARIA rule that is basically checked in a syntactic fashion. So you can easily immediately parse the HTML file and able to assert from the syntax whether these rules are satisfied or not. However, there are higher level semantic aspects that have not been tested. So for instance, one example of a semantic ARIA rule that says any region of the page that serves a navigation purpose should be marked with the attribute role equals navigation. Now, there is no syntactic way to assert whether a region serves a navigation purpose or not. So this requires a high-level semantic understanding of the page, and the existing tools currently don't do that. And that's what we're trying to focus on in this work. We're trying to do this sort of high-level semantic testing. So this is a high-level overview of the approach that we're proposing. So we first start with a web page. So this web page is loaded into a browser, and so we have the final rendered web page. And then what we do is we start with the semantic grouping of that web page. So what this means basically is that we're trying to break down the page into meaningful regions that could be potentially having a certain role or semantic role. Regions that could serve a potential semantic role. So once we have those semantic groupings, we proceed by trying to infer the role for each region. So you have, for instance, you could have a region that serves a navigation purpose. So this region allows you to navigate between different regions of the page or different contents of different parts of the website. You could have another region that serves the role of a search area. So this region allows the user to input the search query and then execute it and so on. So once we inferred these semantic roles for each region, some regions could have semantic roles, of course, and some regions do not have any semantic roles associated. What we do is that we check that the markup of the page, the HTML markup of the page, conforms to the roles that we have inferred. So in this fashion, we're trying to see if whatever the user is able to visually perceive, so for if a sighted user is able to perceive a region as a navigation menu, then this visual perception, this perceived role, should be conveyed also in the markup, the HTML markup. And then we generate a test report of the findings. So basically, for each region that conforms to its inferred role, it takes a pass. And then for each region that does not conform or does not convey that its perceptual, its role, its semantic role, then it's marked as an accessibility failure. So then for our evaluation, we have two research questions. The first research question is, how accurate is the process of inferring the semantic groupings and the roles that we have identified? And then the second research question is, once we have figured out the accuracy of the inference process for the groups and the roles, we want to see to what extent can we detect actual accessibility failures in real-world web pages. So for the first RQ, we have 10 random web pages from the top 500 websites. So these are websites like Amazon, Google, and so on, like from the top 500 websites on the internet. We select 10 random pages, and then we have 10 participants to evaluate the precision and recall for the grouping and the role inference for those 10 random pages. And the results were as follows. For the grouping inference, we had F1 of an 87%, so this is the average for all subjects. And then the role inference was around the F1 for the role inference was around 90%. So it's a relatively good accuracy. Now for the second part, the accessibility failures detection, we do it in two parts. First, we start with a fault injection process. And in this process, what we do is that we start with a test subject and then remove semantic roles from that test subject, and then run the approach and detect accessibility failures, and then see if the roles that were removed were detected again. And the reason for doing this is basically to have a ground truth for our evaluation, and of course it's a lower bound for the evaluation, but it provides an unbiased or like an objective ground truth for the evaluation. And that's why we complement this with a direct examination of the reported failures for a large number of subjects. So we have 30 real-world subjects, 15 of which are top websites and 15 of which are random websites. And then the results are basically 77% of the faults were detected, and the reported failures had an F1 of 85%. So to conclude, existing tools only do syntax checks. They don't have any. They don't do any semantic assessments. We do so, and we do using groupings and role inference, and then the F1 measures were higher than 85% for both semantic failures and inference of groups and roles. Thank you so much.
Okay, welcome again to this session, Testing General Issues. I'm Claudia Ayala from the Technical University of Catalonia, and I will present the last paper of this session, that is Semantic Web Accessibility Testing via Hierarchical Visual Analysis. I'm glad to present the author, Mohammad Bajammal, that is here, willing to answer all the questions that you have. I am checking the chat, no questions yet, but it doesn't matter, I have some. So first of all, I would like to congratulate you for your interesting work. Well, here you have some compliments about your work. They say, Ari van der Deusen, a great work and great presentation. I don't know if they would like to do some questions. We will read them. I will take advantage of my position, and I will read some of my questions. As I said, congratulations for your work. I really like to read your paper, not only because of the technical contribution that you do, but also for the impact, that the potential impact that could have the results, especially for people with some kind of disabilities. And as in the paper, you focus on people with visual disabilities. So I think the impact is valuable. And I also read that you implemented the tool and have some promising results in terms of inference accuracy and ability to detect accessibility failures. So which is very nice. But my question is, how feasible will be to broaden the scope of the approach? I mean, so far you approach people with visual disabilities. So, and I also suppose that you talk in the paper that you approach or you have a set of web accessibility violations. So is it possible, or is it not so difficult, let's say, to increase this set? I mean, to make the scope of this set broaden?
Yeah, that's a very interesting question. It's true we focus on visual disabilities in this work, but the extending it to broader kinds of like sensory like the disabilities, audible disabilities, or some kind of other disabilities, is going to involve more challenges because of the underlying technology. So the existing technology is based on screen readers. Yeah. So it's by definition substituting visual communication for audible communication.
Yeah.
And so it's the stage where the technology is right now is mostly focusing on substituting that visual with audible. Now, how do we address audible disabilities? That requires some other interface other than screen readers. And most of the rules and web standards right now were sort of designed with screen readers in mind. Yeah. So it would definitely require. It is possible. I'm not saying it's not possible. You have interfaces where you can communicate the information through like sensory, like physical sensation. It's possible, but the web standards are not there yet. They're not. They're not geared towards that. Yeah.
And for the case that, let's talk about visual disabilities. I mean, even in this case, I mean, you now are working with a limited set. But I suppose that as the technology improves, probably you will be able to increase or to make this set more bigger, let's say, with more.
Yeah. Yeah, true. That's true. What we wanted to do is basically try to provide sort of like explore this as a proof of concept, because it hasn't been done before to communicate this in a semantic, like visually analyzing the page from a semantic perspective and communicating that. But yes, we focused on the most sort of like common and important subset. That's true. Yeah. In order to have like a proof of concept if this is going to work or not. But in future work, we can definitely extend it to have like more features and cover more subset of the area stand. Yeah.
And does it have sense to think about well, now, as you say, this is a kind of proof of concept. You have a small set, but if we think bigger, let's say, it has sense to think in having a catalog of some kind of violations for different disabilities or for different aspects of the visual disability?
So visual disabilities are usually, I mean, it's like a spectrum. It's not one kind of visual disability. So some people have like sort of like tunnel vision. Some people are completely like they don't have any visual stimulus at all. So it depends on the like the level of visual disabilities. But most screen readers and what in the area web standard was basically meant for like complete absence of it. Assumes that there is no visual communication at all. So so regardless of what kind of visual disability it is, it's still being assumed as if you don't have any visual communication at all. I don't know if that was your question or not.
Yeah, well, it's a premature think on the question that I did, because I say that you now have very few patterns, let's say.
Yes.
And I was thinking on having a very
a larger
big set.
one.
Yeah, but we have another question here from Ari. I might have missed this, but what is the meaning of semantics? What types of semantics do you support? Navigation, search? What about payments? Booking a holiday, watching a movie, etc.?
Yeah. So that's a very interesting question. So basically, the semantic aspects that we cover are whatever semantic roles are defined in the area standard. So the area standard has a set of semantic roles that they define, and basically screen readers are supposed to support that also as well. And these semantic roles were identified to be like the lowest, most common subset of. So this is in accessibility research. They've done usually like studies on users with disabilities and how to communicate, how to like delineate the different areas of the page in terms of semantic functionalities. And what they reached to, the conclusion they reached to, is that these set of semantic roles are the most useful and broader in terms of communicating with users. So that's what the in the area standard is, and that's the sort of the features, the semantic roles we're trying to identify. So they're not like semantic roles in terms of like as the examples are mentioned here in terms of booking holiday or like watching a movie, but they're sort of the function of each region in terms of its role in the page structure itself. So is it a navigation region? Is it a search region? Is it the like the footer or like footer of the page, or like what's the functionality or the role of that region in the page itself, but not in terms of.
No, sorry, continue.
Yeah. So it's like it's that kind of semantic, like the role of the region in the page itself.
Well, as far as I understood, it refers to technical semantic and not the semantic from the point of view of the end user.
Of the domain, of the application domain, yes. Yeah, it's the semantic of the page structure, not the...
Exactly.
Not the domain, the application domain.
Ari says a comment. So a payment provider like Stripe or Aiden could offer extra roles to make payments usable for sight-impaired people?
So I'm not sure. So there's another comment that says, got it, thanks. So I'm not sure if we answered that question or not, but I'm going to comment on it anyway. So basically, like I mentioned, the set of semantic roles are predefined in the area standard. There are provisions where you can sort of like provide custom, tweak, like custom like tags or add extra information to indicate like subcategories of the semantic roles, but they're not guaranteed to be supported by screen readers or other technologies that are adopting the area standard. So the standard only specifies these small subset of semantic roles. So if Stripe or some other payment provider wanted to add extra roles, they can do that. I mean, but it's not going to be supported by the rest of this ecosystem of accessibility tools.
Okay, so I understand. We are almost running out of time, so I will take these last minutes just to congratulate you again and to say thank you to the audience. And to reminder that if you want to continue the discussion, the audience can move to the discussion room. Mohammad will be there for discussing with you further all the aspects of his paper.